Hello, I'm Sung Yoon, the main instructor of this course. You are attending the class of this CS380 undergraduate computer graphics. Today, I'd like to give you the introduction of this course. I've worked on a lot under this computer graphics. I actually had many these experiences, also some knowledge. So based on my prior experiences on the field of computer graphics, I'd like to give this lecture to you. This actually is slide showing my overall research trend. I'm mainly working on designing scalable intelligent computer graphics or this geometry algorithm to efficiently handle the massive models. So I'm mainly working on the photorealistic rendering in the computer graphics, also many other related problems in the computer vision, also the motion planning, further the robotics. But actually, I'd like to talk about this computer graphics field based on my these prior experiences on this field. So these are some of the information about myself or about the course. Actually, I'm Sung Yoon. This is my email address. This is my office location. So basically, due to the big size of this course, I'd like to give it this online course or online lecture through this YouTube or the Zoom session. Also, this is our course web page. So officially, initially I thought that we will have the offline course every Monday and Wednesday, but since there are too many students here, we will have this YouTube video and Zoom session, basically the online lecture. Also, please note that this is actually a 4-credit course, so there will be some of the OpenGL course or some other talks on some of the recent technology for helping you to understand the field of the computer graphics. And these are actually TA. We actually had a very good setup that is TA. So you can also communicate with this TA email address. But actually, I recommend you to interact with this TA through this KL MS board for sharing the main Q&A with other students. So basically, if you actually share your question in the KL MS board, the TA will go over the question and try to answer. And then these many other students also can look at our Q&A. So that way we can understand better. We can achieve the better understanding on the field. Also, you probably need to use the KLMS for the homework submission. Also, homework submissions. Also, the many other class activities. So these are actually the prerequisites. So we assume that you know the basic knowledge of the linear algebra, and basically some of the computer graphics actually rely upon some of the basic linear algebra, like this matrix multiplication. Also, we assume you have some level of this programming skill, especially the C and C++. Many computer graphics actually applications require very fast runtime performance. That's why actually we typically use the C and C++. So, but unfortunately, we cannot give you the lecture on the basic C language. So we assume you can follow or you can self-study on this C-like language. So if you're unclear, please share your questions through the KLMS. Then we will give you some of the interaction to your questions. So this showing the general structure of the overview of this computer graphics or the many other fields. Computer graphics, basically we start from some type of model, and then we run some algorithm, and in the end, for the computer graphics, we need to produce some sort of image or video to the user. So typically we are using some sort of this triangle for the modeling, but there are many other advanced technology for this modeling. Also, here actually we'll talk about mainly the rendering techniques. Also, we'll touch on this rasterization techniques. Also, some of the recent ray tracing or the Monte Carlo ray tracing technique as one example of simulation for the rendering process to generate the image. But also, there are many other related fields like computer vision involved this process. Basically, computer vision look at the image or video and then try to understand extract this modeling information, like what we are looking at here. And the image processing typically deals with this image, right? You probably use the Photoshop as a tool of the image processing. The Photoshop case, actually, you read this image and then you do some sort of process, right? these are actually the traditional field of the computer graphics, vision, and image processing. But recently, thanks to the advance of the deep learning or the AI technology, also there are actually new trend, basically the generative AI to do this image and video generation. So I hope that we can actually talk about some of those recent AI-based techniques. Basically, you probably experiences many applications of computer graphics. There are many games, movie. I will show some images. This is a very old movie, 2D games and 3D shootings. Also, there are many these large-scale games. Like I'm showing this Witcher 3 that I played about 6 years ago. But there are many recent large-scale open world with high-quality rendering. Also, there are many these high-quality mobile game. Also, you know that actually this game industry, the mobile game industry, actually very big industry in South Korea. For the movie, also there are this very old movie, but they're actually generated based on the Toy Story. Actually, one of the computer, the CG generated movie. Also, this one sequence of Matrix, where we are using some sort of this computer vision, computer graphics technique to generate this kind of the scene. Also, there are 3D movies, Avatar, some of the recent ones. Also, recently also we are using there are lots of talks about this head-mounted display HMD. This guy actually wearing some sort of the HMD for virtual reality or augmented reality. Also, recently Apple actually released this Vision Apple Vision Pro to do this kind of they call it this a special computing. They build some sort of augmented reality on top of the real space. Also, the Facebook Meta also have its own device. Its name, I guess, the Meta Quest. Also, there are many other interesting applications like the augmented, this kind of Pokemon Go for the augmented reality. Augmented reality is that on top of the reality, we actually augment these real images through some sort of computer generated character and other ones. Also, there are many other applications like this for this product design and analysis. Typically, for this kind of manufacturing, we need to rely upon some sort of computer-aided design. So for that kind of modeling, and then we definitely need some sort of the computer graphics related technology. Also, the medical application for visualizing data of CT, MRI. Also, we are using some sort of the underlying technology. Some of these basic computer graphics tools like this volume rendering. This actually visualization of the mouse skull based on this volume rendering. But some of the recent AI techniques also based on this kind of volume rendering techniques. I will get back to that issue later on. So not just the image generation. Also, we use some sort of we use actually this rendering technique for even generated sound. I cannot play the video here, but actually also you can just assume that you can know that actually we using this ray tracing technique to generate the image or also the sound. Also, not just just computer graphics application. The recent this AI technique require lots of the realistic data. But we can use the many computer graphics, the technique, basically the computer graphics resulted in the very advanced technique to generate this kind of the realistic modeling, rendering, and simulation. And then based on that, we can generate some sort of synthetic data. Then it's not real data, but basically achieving collecting real data is very expensive. So we can actually using this kind of CG technique to generate this synthetic data in addition to realistic data. That we can design the many AI technique or deep learning technique to do the robotics and many other applications. So basically, I'd like to also point out the computer graphics, not just for the graphics application, but other the recent AI technique. We're also using this kind of CG technique, also the GPU a lot. Obviously, the GPU a lot. So there are lots of topics. We will talk about some of the basic topics, like some of the basic mathematical tools, and some of the basic modeling interaction techniques, and how we can actually generate images through from this kind of the models. We'll talk about the rasterization, depth buffering, and then we move on to ray tracing, ray casting techniques. rasterization is one of the basic concept of the generating the pixel image from this kind of triangle, and then other one lighting and shadow and texture mapping, blah blah blah. Also graphics hardware. There are lots of topics, but we cannot cover all of them. But we will talk about some of the main concepts. Also, those actually the topics actually the actually they prepared this book to cover those concepts. So if you are these are actually our textbook, but actually this is actually freely available. If you click this link, you can see there actually this homepage of this book. Also, you can see each chapter or the whole book is there freely available. You can just watch you can read this one through just PDF. Also, there are many references for if you are interested about the OpenGL programming. This also available at the KAIST library. Also, this the general typical the textbook of computer graphics also available at the KAIST library. There are many these rendering techniques the books. You can also check out them. Also, I think that I already prepared them in the KAIST library. But I wish that in the class I wish that you can touch on some of the recent technology, so that I give you the homework to go over the technical paper, and then one of the main conference the venue for the novel technique is actually SIGGRAPH Asia. So the SIGGRAPH also in the field of computer vision, CVPR, ECC also one of the top the venue. You can, if you click this one, you can see the many recent papers. But not just this paper, you can learn lots of things by interacting with ChatGPT. Obviously, ChatGPT does not give you the correct answer, but you can get the rough idea about the field. Then obviously you need to search from that keyword. Also, there are many references from our course homepage, Google and Google Scholar to search this homepage, the paper. There are many this problem assignment. So there are about 5 or 6 about basic computer graphics, rasterization, or some of the ray tracing. And then obviously unfortunately we cannot teach you the basic C and C++, but these are actually the programming based on the C language. So you should be able to you should know this basic C like the language. Also, you need to be able to self-study on the C like language. Also, there will be many quiz. We will frequently have this quiz session, which also serve as this attendance check. So if once there are some sort of the quiz session or the Zoom session, you need to attend those sessions. These are actually the homework for everyday class. Before you come to the class, before watching this video, I recommend you to go over the lecture slide before watching the YouTube. That way, just spending 10 minutes, 20 minutes, you can get the better understanding what will be done, what will be actually talk about in the class. Also, you need to go over 2 paper or the video. One nice thing about computer graphics is that virtually every paper comes with the video. So if you are watching reading the paper is very difficult, but you can watch the video and get the main idea, right? So you need to go over browse the paper or the video. You need to do 2 video summary, and every week. So even starting from this week, so you need to go watch the paper and video, and provide the summary, your own version of summary. You should not copy and paste this abstract of the paper. Just a simple submission before every week, before every Monday class. So probably during this week you need watch go over 2 paper, 2 video, and before the next Monday class, submit each abstract. So we'll talk about this information. We'll talk about this one later more. But basically, by doing that every week, I will actually guide you to do the paper presentation, which will come later on. Also, I'd like recommend you to come up with the questions, so that actually I can understand what's unclear to you. So you need to do the questions submission 2 times during the whole semester. Obviously, you can write down some questions through the KLMS, but they will also count. But I'd like to encourage you to come up with the questions. Basically these are actually one of the main maybe the main homework or the main challenge to you. So I'd like to ask you to each one. I'd like to ask you to the student lecture, also another paper presentation, which actually relate to your interest. But obviously that should be those lectures should be related to the computer graphics. And then basically I think that by doing so, I think that you'll be more prepared for your long-term career, which long-term career. The better the long-term career, the path. So obviously, just listening to the lecture is not enough. You need to do, especially since we have the ChatGPT, everything, basic knowledge already. You can actually access those knowledge through the Google search or even ChatGPT. I'd like to encourage you to motivate yourself to interest about some topic, or motivate yourself to learn a new topic on this computer graphics. So also you can make a team. You can do solo team, or you can make a 2-member. I think that having 2 members is the better for you to discuss. You can learn something new, a better one. But you can do the solo team also. You can make the two team member. But for each team, you need to do these 2 presentations. One is student lecture, and also the paper presentation. So I will talk about I will give you more information about them later on. But basically, student lecture is more easy, more the basic knowledge. But for the paper presentation, you need to talk about more the advanced, more recent techniques. So I will give more information, but there are main difference between the student lecture and paper presentation. But anyway, you need to learn something new, and you need to talk about something a new topic to all of us. And obviously, you need to identify the lecture topic. Also, you need to also identify the recent paper to present them in during this semester. For this lecture topic, I will provide some of the keyword, some of the topic list. But through the list, for this homework, by browsing 2 paper every week, you can know what are the recent trend of the research, and then you can present some of them in the class. These are the tentative grading. 30% for the exam, also another 30% for the attendance, quiz, and assignment, another 40% for the student lecture or the paper presentation. So you can see that the student lecture, understanding the topic and presenting them in the class is the most important class activity here. This is our late policy. No score for the late submission. In other words, you submit whatever your result, your work before the deadline. These are the class attendance rule. If you are late 2 times, for example, actually there's Zoom session, then you should attend the Zoom session. Probably in the beginning or the late of this end of Zoom session, I will call your name. And if you are late 2 times over there, then I will count it as 1 absence. Every 2 absence, I have to lower down your grade. For example, based on all other activity, you got the A minor. But you absent 2 times, actually I have to lower the 1 grade. In this case, A minus to the B plus. So to check the attendance, I will call your name, or the TA will take maybe take the picture of this Zoom session. If you are in a situation where you cannot attend you cannot attend or late, you should notify TA me earlier this class time. This is a general honor course. I recommend you the collaboration among your team member or the other classmate. But assignment should be done by yourself. Also, if you are utilizing someone else's code, you need to cite any other's work if you are using their code. If you just copy someone else's code, obviously you will get out. So sometimes also TA might be used to this code copy checking tool. If you have the offline class, this is class etiquette, but mainly we have this online class. English is actually our main official language in the class. I give the lecture in English, but sometimes actually I use the Korean if some material is not unclear to you. But whatever Korean I used, I will actually summarize them in English again. Also, you can write down the question in the KLML. You are recommended to use the English, but it's unclear. it's uncomfortable for you, you can use the Korean over there. It's not for your side, using the English is not required. These are actually some of the basic basic structure and guideline about this course. Next time I will talk about some of the basic structure of the computer graphics, the application. I will talk about screen and workspace. I will talk about basic OpenGL usage. So far I talked about myself or this lecture, but I'd like to know about your name and your major, your prior graphics experience, and some other questions. You can do you can provide this one through this form. I recommend you to that within today, within the Monday. Let me access this link from the computer over there. Okay, if I click this one, it will be linked to the okay. Sometimes in some of the case actually this might not open up the link properly. Then I recommend you to copy and paste this link directly and paste it to here. Then yeah, here actually the thing you need to write down your student ID, your name and your major and your prior experiences and so on. Also you can provide your the question here, and here also this is our course homepage. CG. I don't know why I have this incorrect. EUI and CG. Yeah, it's our course homepage. This class Q&A is a link. Basically, it will lead to the KLMS, the question board. And here actually some of the information about the book. If you click this book, actually this is the main textbook rendering. You can see the whole material about the rendering, the whole this one, the rasterization and many different chapters. This is actually physically based rendering about multicolor ray tracing. We'll cover some of main concepts about them. And then I will the TA will upload some of the lecture material here. Also you can access the YouTube videos through this one. Yeah. Okay. That's about it. Then that's it. Thanks so much. See you later again. Bye.